Students, now let us see the next theorem, that is, see the statement what is given. The segment joining the center of the circle and the midpoint of its chord is perpendicular to the chord. Okay, so what is given? See, segment AB is the chord of the circle. See here, this is the chord of the circle with center O, and P is the midpoint of the circle. That means AP is equal to PB. What you have to prove is OP. It is just the opposite of previous theorem. There it was given OP is perpendicular, so you have to prove AP is equal to PB. Here AP is equal to PB is given, you have to prove OP is the perpendicular bisector. Okay, now let us see how to prove it. See the first statement of the proof that says that draw OA and OB. You just have to draw these two lines. Okay, now let us see the two triangles, that is AOP and triangle BOP. Okay, the two triangles we will see now. Okay, so OA is congruent to OB. Why? Because it is the radii of the circle. See the first statement, OA will be equal to OB because radii of the same circle. Now OP will be equal to OP because common side. Okay, AP is equal to PB. Why? Because it is given in the question. So therefore I can say these two triangles are congruent by SSS test. See, three sides I have proved common, 1, 2 and 3. So therefore the two triangles are congruent by SSS test. Now therefore I can say angle OPA is congruent to OPB. Okay, why? CACT, that is congruent angle of congruent triangle. Okay, but I have to prove that it is 90 degree. I just proved that these two are congruent. Okay, now OPA plus angle OPB will be equal to 180 degree because these two are in the linear pair. Okay, now therefore now these two angles OPA and OPB are congruent angle, so this I can write as 1. Okay, so I am writing OPB. Okay, so OPB plus OPB is equal to 180 degree. Why I am writing 2 times OPB? Because OPB is equal to OPA, so you can write it as 2 times. Okay, substituting the value, see here from 1. Now 2 OPB is equal to 180 degree. Okay, therefore 2 comes here, divided by 180 you will get 90 degree, hence proved. Okay, so therefore segment OP is perpendicular to AB. Understood everyone? Okay, now using these two theorems we are going to solve our sums. Okay, now I'll show you this one example of the sum. See the question here. Radius of the circle is 5 cm. The length of the chord is 8 cm. You have to find the distance from the chord. Very simple sum. You have done this in 8th standard also. Okay, so first thing I will draw the circle. You will draw the radius. Radius is given as 5 cm and chord is also given. The length of the chord is 8 cm. See here, chord is PQ. You can take any name. Here in the question no name is given. So let us draw the figure from the given information. O is the center and length of the chord is 8 cm. Okay, OM is perpendicular to PQ. Okay, segment OM is perpendicular to PQ. Because we know that the perpendicular drawn from the center of the circle on the chord bisect the chord. See, OM is perpendicular to PQ. That means OM is bisecting PQ. So therefore I can say PM is equal to MQ is equal to 4. Half of 8 is 4. Okay, now radius of the circle is given 5 cm. So OP and OQ both are 5 cm. So I will use triangle OMQ, this triangle. Okay, here we will apply Pythagoras theorem. Okay, so OM square plus MQ square is equal to OQ square. Now substituting the value, you will get OM square is equal to OM square plus 4 square is equal to 5 square. Always you will write the values which are given, okay, in the equation which you have formed. Then arrange it and solve. Okay, so OM square is equal to 5 square minus 4 square. That is 25 minus 16, you will get 9. okay, but it was in OM square, so you want OM, so the square root of 9 is 3. Hence the distance of the chord from the center of the circle is 3 centimeter. Okay, understood everyone? Now one more example is given here. In this, see the second example. Radius of the circle is given 20 centimeter and distance from the center of the circle is given 12 centimeter. You have to find the length of the chord. Okay, so I will draw the figure first. Circle, radius, chord and perpendicular. Always remember that sums which are based on circle, this figure will be there, one chord will be there, one radius and perpendicular bisector will be there. Okay, now let the center of the circle be O and radius OD is equal to 20 centimeter. It is given in the question. Okay, now OP is given as 12 centimeter. Distance of the chord from the center, this is chord and this much is the distance. Chord from the center is 12 centimeter. Therefore OP is 12 centimeter. Now CP is equal to PD. Okay, perpendicular drawn from the center bisect the chord, therefore CP is equal to PD. Okay, now I will use this triangle OPD. We will apply Pythagoras theorem to it. Okay, that is OP square plus PD square is equal to OD square. Always write in the basic form. Don't change the Pythagoras theorem according to your given values. Don't change the names here. Okay, so OP side 1 square plus side 2 square is equal to hypotenuse square. Always follow this pattern. Okay, now I will substitute OP. OP is 12 square. PD is not given, so I will write PD as it is. OD is given 20, so I have written 20 square. Now I will arrange. Okay, after arranging 20 square minus 12 square, see here, after splitting you will get, therefore PD square you will get 256. PD square is 256. So PD is 16 centimeter. Okay, so PD is 16 centimeter. Now if PD is 16, CP will also be 16. So PD and 16 both are 16. But what is, see, don't think that 16 is your answer. Here what is asked is length of the chord. What you have got is half length. You have to add now. So therefore length of the chord is CP plus PD, that is 16 plus 16, 32 centimeter. Okay, understood all of you?